after 1 o'clock. Our flight crew will depart the ONC just before 2 o'clock in the afternoon, and we'll count down. We'll get them in the ship. We'll do comm checks, make sure all of that's good, get the crew module configured, and we will count down to our T-minus 10-minute hold. Once we finish up that 30-minute hold and all systems are go, we'll pick up the count and we'll count down to our T0. So that's a little bit about our milestones and kind of where we are. It is an exciting time. It's an exciting time for this team and our crew and really our nation and the world. So we'll, as many have said, even yesterday and as we talk about in all of our management meetings, we'll fly when this hardware is ready. We'll see if it's ready to go in just a couple of days. But certainly all indications are right now we are in excellent shape as we get into count. And with that, I'll hand it over to John.
Thank you, Charlie. Let's see. It's L-2. Glad to be back with you folks. Amit gave you a good overview of the L-2 mission management team meeting today, so I'm going to talk to you a little bit about why we do it and what the process is. So it's an important checkpoint following the agency flight readiness review. It's not intended to be a rerun of the flight readiness review. Rather, it's a chance for us to get together and do three things. Walk through the work that we've closed since FRR, walk through the work that we're still doing, and then discuss any new issues that are out there. So today we took a focused, disciplined look to validate the work we've done and make sure that the path to the next milestone is clean, deliberate, and fully aligned. Before we polled the mission management team for go, we had a verbal roundtable allowing all the program managers and advisors an opportunity to ask any remaining questions. There were none. Before I polled the team, we took about a 10-minute break. I like to do that to let folks that are might be a little bit intimidated, get questions to folks that are willing to speak up on their behalf. We got folks to get back together. Again, there were no questions, and then finally we conducted the readiness poll and for launch operations, and we had full concurrence and where we're go. So with that, I'll turn it over to Emily.
Thank you, John. And again, I'll thank everybody for coming. We really appreciate your support. Our teams in mission control and our crew members have spent the last over a year, 2 years, dedicated to training for this particular mission, developing all of the products associated with this flight, and they are ready to go. Our crew members, Reid, Victor, Christina, and Jeremy, they've spent the last couple of days here at the Cape since they got here on Friday, getting an opportunity for some rest before we work them very hard. They are getting an opportunity to spend some time with their families. Tomorrow they'll get a few last-minute briefings and meetings with some of the team before they head into launch day, as Charlie spelled out for you. As we come to this really exciting moment, the opportunity is immense for us to finally get the opportunity to send our crew farther than anyone's gone before. And it's an incredible moment for the Artemis generation, and we're excited and we are ready to press. I got the opportunity to talk with Reid earlier today, and when the teams are ready and when the spacecraft is ready, the crew is ready and excited to go. So with that, I'll hand it back over to Courtney.
We will go ahead and kick off our Q&A portion of the briefing. If you have a question here in the room, please raise your hand and we will get the microphone over to you. We'll start right here in the front.
Hi, thank you for being here with us today. And my name is Jim Siegel. I'm with Florida Media Now, and I'm curious about the kinds of cargo, whether it is food or experiments or whatever, that have been loaded on the spacecraft last. And when was that? And if there is a delay in launching for, say, a week or two, Does any of that cargo have to be replaced? Thank you.
I can take that. Our turnover for our last stow, so we do have a stow in launch countdown. It happens somewhere between about L-30 and about L-24. We have the Avatar that will go in, and of course that is provides us insight into effects on tissue. We also have the zero gravity indicator, and then some other late stow items. And we have 4 bags that are going in, and then certainly if we end up in an extended scrub, then there are change outs associated with some of that, and that's pretty standard for our timelines. We look at all of our scrub schedules. We have destow and restow ops.
Thank you.
Mm-hmm.
Okay, we'll take another question here in the room. Let's go right here.
Hi, Ken Kramer, Space Up Close. Thank you. Thanks for all the work that you're doing. It's fantastic. My question is for Amit. Since you mentioned the future architecture a little bit, I'm curious, you guys were planning to do uncrewed test flights of these lunar landers, the human landers, about a year ahead of time in the past. I'd like to know what is the plan now? How is that all going to work out?
Still going to do those. We still need to make sure we can land robotically with those machines before we decide to commit the crew to them, but we're trying to get early data on the life support systems, the rest of their systems ahead of time, which is why we want to do Earth orbit activity to make sure we can shake that out while they're concurrently pressing towards doing landing attempts as well. So we haven't taken that off the plan.
When would it be?
Right now, we're planning on uncrewed landings next year in 27. We're working with the vendors to bring those in. I think that's been the baseline plan for a little while. We think we can hold to that, but again, it's going to depend on a lot of milestones coming up, like propellant transfer, et cetera. So we're working with them to do everything we can to get side by side with them to help them. But we have to land uncrewed before we're willing to commit the crew to a landing mission. Yep.
Okay, we'll take one more in the room right here, and then we'll head to our phone bridge.
Yes, Frederick Castell with France 24 Television. You mentioned that the crew was resting with a family. Is there something similar, like the beach house they had in the past, have been to the beach or something of this kind? Thank you.
Yes, this evening they'll get the opportunity to have dinner with their families at the beach house. So they've gotten to spend most of today with their families, and tonight they happen to be at the beach house.
Okay, we'll head over to our phone bridge. Our next question is from Bill Harwood with CBS News.
Yeah, hi. I've got a really trivial question for Emily. A lot of folks are calling this a 10-day mission, and the flight plan that I've seen shows it a 9-day, 1 hour, and something minute mission. And I just wonder if you've set the record straight. Do you round up 9 days, 1 hour to 10? Or should we be calling this a 9-day mission? Thanks.
So we're going to keep calling it a 10-day mission. In general, though, if we launch on the 1st, we're going to land probably on the 10th. I don't want to dare the space gods by trying to say I know exactly what's going to happen and exactly how the burns are going to go, because obviously things change in flight. But yeah, generally our planned launch. For a planned launch on April 1st, we come down on April 10th. So if you just do basic math, that's maybe not a whole 10 days, but I'm going to round up.
Okay, our next question is from Christopher Mick with Hudson Star Observer.
Thank you so much for taking my question and for you all for your time today. I just had a couple follow-ups, I think, that were mentioned at the briefing yesterday. I think Dr. Glaze mentioned about some outstanding medical equipment that needed to be secured at the different kind of abort locations, and that was ongoing. And then just maybe with Charlie Blackwell Thompson, maybe to follow up on just if there's been any update on some of the comms issues that were happening before. Are those kind of ironed out and working well?
Were you guys able to get that?
Yeah, so actually this is a wonderful. This is why it's great to be in America, because we're literally during this presser like, sorry, your question got walked on because there's another launch going on right now. We all looked at each other like, I don't think there's earthquakes in Florida. It's definitely a launch. So anyway, we have to wait for the boom too, but I don't know if that's coming down. The boom will be quick though. Can you repeat your question online? I think we're clear now.
Okay, yes. I was just asking, kind of following up from yesterday, I think Dr. Glaze mentioned some of the medical equipment that still needed to be secured at some of the abort locations. Was just checking on the status on that. And then maybe for Charlie Blackwell Thompson, we just wanted to see if there's any update on the comms issues since you have people on the countdown now, if that's been ironed out and working well.
Okay, I'll take the first one. Yeah, one of the actions we took from FRR, I think this is what you're referring to. There's also some late stow medical kits because we want to make sure we maximize the efficacy of those. I think that's maybe in the last 4 bags, but typically we add those things late. We also did want to make sure that our transatlantic abort regions had the right equipment just in case we had to divert and during one of those longer abort scenarios. And so we did. JD Polk and our health and medical team has been in active negotiations with a lot of our partners across the other side of the Atlantic to make sure that those facilities are ready. That was an action coming out of FR, and that was closed today, with which we're holding open maybe a signature or two. But separately, we have made contact with all those facilities, understand their capability and procedures, and they're ready to support us. So you want to take the other one?
Yeah, I'll take the one on the comm. So we've done a number of things relative to the comm system to make sure that we're in the best configuration that we can be in. We actually did a big comm test before rollout, and it worked very well. We didn't have any issues. As part of that, we did a system load, had the firing room full of folks just to make sure that it wasn't related to how much load you had on the system. We've also added some rigor into the network that we have and the ability, in the event that we have an issue, that we can go isolate that node of the network. And so that was a change that we put in place, and we tested that out. And so when it comes to the communications issues, each and every one of the items that we have found that have contributed to comm challenges, all of those have been addressed. And so based on what we know today, we expect to have nominal comm throughout the countdown. Certainly, you can have hardware that breaks, and so if something else or something new were to happen, we will do what we always do, and we'll assess it and we'll address it in real time. And then also during wet dress, we did utilize a contingency procedure that we have for utilization of radios within the Launch Control Center for certain types of operations until you could get comm fully functional again. So I think we're in a good spot relative to comm, but there has been significant work on it over the last several weeks.
Okay, we'll take some more questions here in the room. Let's head to the back on this side. Jackie?
Hi, thanks for doing this. A quick question for Mr. Honeycutt. I just wanted to know, were there any details you could share from the meeting today about specifically what items you were discussing? And then I know you mentioned in a previous news conference that not all decisions have to be unanimous and you have the final call. I was just curious if you've run into any instances yet where things haven't been unanimous.
Well, the only ones that I can recall that were not unanimous was when we were working, when Charlie brought some MMT things to us during the sim. They were only sim related, but none of the other stuff, it's been pretty smooth. What was the first question?
What closeout items you discussed today during the meeting?
They were pretty easy. Amit mentioned one of them relative to getting a signature on a piece of paper, so we're carrying that open. We got some work going on with one of our remote satellites to get the mechanism that tilts the satellite repaired and getting it back up and running. That work was ongoing while we were in the meeting, so we'll get notified later on. I'm pretty sure that got worked out. We talked a little bit about a gas analyzer that's on the Orion capsule. Got satisfied with the minor challenges that we had with that. So those kinds of things. It wasn't anything big. No showstoppers. Nothing that gave us pause for concern. Said, hey, we got to come back tomorrow and do L-1.
Okay, let's take a question from this side, right here on the second row.
Hi, Philip Sloss. I think this is for Charlie. Previously, you talked about a part 2 of the countdown demonstration test. Were you able to do that with the crew out at the pad?
So part 2 of the countdown demonstration test was intended to be a walk down of the emergency egress system and just a refresher. We are doing a refresher with them this evening, actually, in a briefing format, and they have been back out at the pad and have had an opportunity to take a look at it. But in terms of calling it a CDT Part 2, we did not do the CDT Part 2 procedure, but we certainly will be covering the material with the crew tonight just to make sure that it's exactly as they remembered it and they have had an opportunity to be out at the pad. Mm-hmm.
Okay, let's come up to the front up here.
Thank you very much. Tarek Malik with Space.com. I think for Charlie, it sounds from what you're saying that everything seems to be going extremely smoothly. I'm curious, are there any open items with the vehicle at all right now? And if not, like, what are the key, I guess, checks between now and tomorrow, that you're looking for to make sure that all the boxes are checked, the I's are dotted, et cetera, for that?
It's a great question. This pad flow has gone extremely smooth, and we have been on plan or ahead of schedule the whole entire time. And so we essentially were able to pull in our launch countdown preps by an entire day. And it worked out great because we finished up most of our work on Saturday. We were carrying one weather day. This was intended to be a 12-day pad flow, one weather day. And we when we finished the work up by Saturday and we're sitting on this weather day, it happened to be on the day where we expected bad weather, so it gave most of the team, or a good part of the team, an opportunity to take a breath, get ready for launch countdown. So that has all gone very well. In terms of constraints, I've been in this business a long time, as many of you know, and I've been through a lot of launch countdown pre-test briefings. And we had our launch countdown pre-test briefing on Saturday. It went a full 3+ hours, very thorough review. And out of that, we were tracking exactly one constraint, one. It was on the LH2 flare stack on the pilot light. And we have 3 of them. We need one to light the flare stack. But we wanted to have full redundancy going into this countdown, even for something as small as the flare stack. And so I'm happy to report at this time that we were able to find the issue with that and correct it, and we are 3 of 3, and that paper's closing. And the last call to the firing room before I came to this briefing, the most significant issue that was being worked at the time was they had a couple of monitors in the spare console that we don't use very often, but when they powered everything up and they were going through all of the checks, they found that they had 2 monitors that needed to be replaced. So, those are welcomed issues. If that's what we're talking about, over the next few days, that'd be great. In terms of what's coming up, I mean, there's a lot of vehicle checks coming up. So, we've powered all these vehicle elements up. We've checked them out. RF's been checked out. We've done commanding during wet dress with the flight control team. I mean, wet dress is as close to launch as you get without it being launch day. And we had a very successful wet dress. So in terms of what am I watching? Well, I'm watching everything, all the way until we get to tanking, and then all the way through tanking. So every check is significant when you're in launch countdown, but I do feel good about where we are based on having a good wet dress and knowing that all of these elements have been powered up during the pad flow. They've all been checked out and maybe not quite put into the launch configuration exactly, but they've all been checked. So.
Okay, we'll take another question on this side, right here.
Yes, Bert Dicht from Ad Astra Magazine, National Space Society. A question for Emily. At a previous news conference, it was mentioned that 25 years of operations in low Earth orbit doesn't really prepare us for going to the moon. So I'm just wondering, what types of additional things have your mission controllers done to prepare? And I'm sure looking at Artemis I, but does looking back at Apollo data offer any guidance or insight?
Absolutely. So Artemis I is, of course, a first step there. Some of the lessons that we learned there, just the navigation in the vicinity of the moon was a little different than what we expected, so we had really great learning there. How to operate this spacecraft in its space environment. You know, when you're orbiting the Earth, you get a lot more eclipses. You have a certain type of environment that you're working in. The environment as we're going out to and around the moon is a very different environment. So we learned a lot about how this spacecraft will operate in its environment. And then, yes, we absolutely refer back to what the generations, you know, the shoulders that we're standing on. We've had, in preparation not only for Artemis II, but also for the lunar landing missions, for the opportunities to walk on the surface, for all of those lessons learned, we go back and we chat with the leaders of those missions on as often as we can get them to come back and talk to us, because we don't want to learn again a thing we've learned in the past. There's too many new things to learn, and so we want to make sure that we've incorporated everything that they've learned as to the extent that we can, and be able to go and explore new territory.
I just add real quick the premise a little bit of your question. I think it's the right one. I think the risk tolerances are different, and you know, leaving LEO is a different kind of mentality, but the life support systems we're fielding on Orion were first fielded on ISS. The main engine on the service module was first fielded on ATV, which rendezvoused with ISS. The health and medical performance, all of the suit designs that we're feeding forward, 25 years of flying space station has given us reliability and understanding of the elements of the machines that we're flying around the moon to a large extent, which is why we're comfortable taking these risks, because we have fielded, if not the exact same variants, but a lot of the same pieces of hardware with heritage from the station program.
Okay, we'll take another question on this side, second row right here.
Thanks very much. Ivan Semenek with the Globe and Mail. For those, this is a question I think for Charlie Blackwell Thompson. For those who are not in the space business, I think countdowns usually start 10, 9, 8. Here we are 50 hours or so ahead of the launch. I was wondering if you could unpack what determines why it's that amount of time, and what's the difference between being in countdown, not being in countdown at this stage, what that means for everyone and for the crew too. Thank you.
Yeah, absolutely. And you know, you could start a countdown, you could decide, and we made a decision based on, I would say, a little bit on heritage, but you could say that countdown started at tanking, and some folks do that, and then it would be from, you know, about that last 12 hours or so. For us, the decision for when countdown started, it was when are we starting to configure the ground systems and the flight elements for countdown. And when you start from scratch, you go and you look at how long is it going to take to do, and you lay it out step by step, and it turns out that it was about 2 days long. If you laid that side by side with shuttle was about 3 days long, so it was longer. If you look at it next to some of the commercial missions, you'll find that they're, you know, a day or less. So we're somewhere right there in the middle, but it's really driven by the work. You could draw that line anywhere you wanted, really, and say it's going to be the last 10 minutes, and all this other stuff is going to be called preps. But for us, what we decided was that it's when you start doing that final configuration of the ground systems and the flight systems. But you're right, most folks think about that last 10 minutes and those polls and getting into those dynamic systems and the final countdown. Yeah.
All right, right there.
Good afternoon, Nelson Castro from Channel 13 and TNA from Argentina. Artemis is taking an Argentinian-made satellite. My question is, two questions. What are the main goals for you for the whole mission, and concerning the information that satellite could provide? No? And also, does that mean that in the future this cooperation with foreign countries in order to take part in the mission is going to be a trend? Thank you very much.
I'll take the second part, and then what do y'all do? Is the payload stuff good? This crew is an international crew for a reason. Our cooperation will, for the previous question, one of the most amazing things about Space Station, I think the most amazing thing was the partnership that was developed to operate that machine. As I said in my opening, we're going to need the free nations of the world to collaborate to build even more ambitious architectures as we expand our range of action throughout the solar system. There's no question in my mind. It's a partnership is fundamental to that, and we're very, very proud to be flying with an Argentine payload on this mission. In terms of the details, I think it's co-manifested, but Emily, do you have that?
I don't have the details on each of the co-manifested payloads, so I'll have to go and look that one up for you.
It's a unique experiment because in this particular case, the way it's on Artemis 1, we had co-manifested payloads as well. Those had a little bit more benefit because they were riding along with the basically propelled by the ICPS. The ICPS for Artemis 1 was heliocentric disposal, and so in which case those payloads are put on that trajectory. In this case, we're doing Earth disposal of the ICPS, and so unless the hardware has some propulsive components, they pretty much they're going to be coming home with that. But that doesn't mean you can't do interesting things with the payload as we go forward. So in terms of the actual details, we know that our exploration operations office has been collaborating with them to make sure that they are loaded. We held extra time in the plan so that we could provide additional accommodation in the stage adapters in order to do it, and our partners delivered the hardware on time. And if it succeeds, we're very hopeful that it does, but the success of those CubeSats is also not integral to the success of Artemis II as a test activity. But every chance we send mass to space, we want to take as much advantage of any extra room we have.
Okay, we'll take our next question on the phone, and then we'll come back here to the room. Our next question is from Marcia Smith with spacepolicyonline.com.
Thanks so much for taking my question. There was a powerful solar flare today, and I had a couple of questions about that. I'm not sure if it's Ahmed or Emily or who would answer it, but I'm curious as to how much advance notice NASA had of the solar flare and whether or not that matters in terms of planning for the rest of the mission. And what would happen if this intensity of a solar flare happened while the crew was out there? And I gather it's not going to have any effect on this mission, or you would have mentioned it already, but I did just want to ask.
Yeah, so Marcia, it was today, but UTC, it was actually last night. It was the flare. We were just talking to Joe Westlake before we came over here, and we talked to her a little bit before that. We're not expecting the CME to cause any effects. There's going to be a light kind of G2 level event in the southern hemisphere. It should dissipate by the 31st in the evening, I think is what Joe said. So we're not tracking concerns for the mission in general. We do have solar weather constraints for launch, depending on the sensitivities of various avionics as we go. So we watch those as we go. We have some of the best teams in the world, both at Goddard and at NOAA, that are watching those things all the time. The Space Radiation Analysis Group reports directly to MCC Houston. We also take advantage of the NOAA SWPC group to go and do the monitoring for us. Of course, we have an incredible telescope staring at the sun all the time. I'd always give the Helio guys a hard time because I'm waiting for them to tell me when and exactly they can predict these flares to occur, because I really, really want that. But again, what we have is pretty quick notification and observation of these events. We can quickly triangulate the direction of any mass ejection and see if it's going to impact the mission. In terms of in-flight radiation response?
One of our test objectives is actually to set up the radiation shelter, so we'll be doing that anyway, even without a radiation event. But basically, we've got a section of the spacecraft that we would set up, and the crew would stay in that area until we gave them the all clear that the radiation event had passed. Sort of like what we do in LEO if we need the crew to shelter there as well.
The only thing I would add is that we do have LCCs on space weather, and those are monitored by our launch weather officer and reported just like any other weather constraint. It starts at tanking and goes down to 6 minutes.
Okay, we'll take another question in the room right here, third row on the inside.
Hi, Lauren Grush with Bloomberg. Thanks so much. I was just wondering if you could walk us through the various abort scenarios and the contingencies for this mission, both during launch and during the major milestones during a flight. For instance, is there a contingency plan if there's a technical issue during the ProxOps demo, for instance? And are there any portions of this flight that really just cannot support an abort or a contingency? Thank you.
Yeah, go ahead.
Yeah. So let me do the ProxOps one first, because that one's fairly straightforward. If we run into any issues, then the crew is just going to begin to back away, and we'll separate the Orion from the ICPS and continue on with the mission. So that one's fairly straightforward. It's a really good demonstration for us to get. Again, building blocks for future missions, we really would like to get that rendezvous, but if we, for any reason, have technical difficulties, it's a pretty straightforward call to be able to back out of that one. In terms of aborts throughout the mission, if we have an issue with the launcher, we've got the ability to either abort into the Atlantic or we can abort into the Pacific, which we would call an abort once around, because you get almost all the way around the planet. And so pre-launch, we'll be monitoring the weather in all of those locations so that we can best position ourselves to keep the crew in a good config if they ended up in one of those situations. Post-launch, we will spend the first day evaluating all of the critical systems on the spacecraft to decide whether we're go for TLI or not. If we decide we are not go for TLI, then we can start setting ourselves to come back from the high Earth orbit, which I don't really think of as an abort. That's more of an alternate mission, because we'll be very deliberate about that. That's not a situation that we'd need to rush. We would go figure out, is there anything else we need to do while we're in high Earth orbit, and then we'll head home. Once we hit TLI, from there you can abort to come home, but you get very rapidly to a point of diminishing returns where you're not going to shave that many days off the mission. After about 24, 36 hours after TLI, roughly, don't write that down, you really don't get a whole lot out of the abort, because it's not like you just turn around and come straight home. You're still on a trajectory that needs to make its way back to the Pacific. And so, and in almost every situation, when you're doing a risk trade, the risk of a highly dynamic burn versus a free return trajectory where we use the gravity of the moon and the Earth to get ourselves back for free, that's almost always you're going to err towards the free return trajectory, because it's a much less dynamic situation. So unless you're in a very time critical situation, you probably don't want to take the risk of the abort. Does that answer your question? Did I miss any of it? Okay.
Just to be precise, I mean, that really, you have abort coverage. Your fastest abort is around the moon rather than turning around and burning for home. That's important. But I mean, we could probably spend several days talking through every other system level contingency, but this is one of the things that we obsess about. So.
Okay, we'll take another question. Back row right here.
Hi, excuse me. Sorry about that. Hi, everybody. Greg Palone, Spectrum News 13. Just saying, is the second a viable launch option? Is there enough turnaround time to be able to have the second? The 45th said in the forecast today it's a 48-hour turnaround. Do you guys see the second as a viable option if there is something does happen on the first?
Yes, I'll take that one. We have launch dates that are the 1st through the 6th. They're all available to us. When we added the 1.4 million gallon hydrogen sphere, that was the driver in Artemis I, the reason that we had to do a 48. So it is certainly available to us. Somewhere in those days, we set up for 4 launch attempts across that set of days. Somewhere in there, you do have to do a 48, though, because you have to go replenish locks.
Okay, let's go second to last row back here.
Excuse me, thank you. Carmen Fuentes, WHNT in Huntsville. So I know that currently the Wednesday weather conditions show 80% favorability, and I know you talked about all the systems and vehicles being good to go. Something NASA can't control is the weather. So if it stays at 80%, does that mean we'd still be go for launch? And at what point, if it were to drop below 80%, at what point would we consider maybe holding off to the next day?
So what happens with the number there with the 80% is we have a set of criteria. Some of them are standard range criteria relative to lightning and other things, and some are specific to our vehicle, like winds and that sort of thing. So our launch weather officer takes all of those criteria, and so when they give us a percentage, that 80% is that there's an 80% chance that we are going to be an acceptable criteria across all of them. But if we're in violation of any of them, then we're going to wait it out. I'll give you, and Mark Berger, who's our launch weather officer, he'll be here tomorrow, and he can certainly talk all the weather in detail, but I'll give you my opinion on the weather. So we have a 2-hour launch window. That's a wonderful thing, because when you look across the forecast, and I was looking at it just this morning, and you look at the winds, I think we're going to be okay from a wind perspective, and really what they're looking at for the most part is cumulus clouds. And so, I imagine that over the course, can't guarantee it, but over the course of a 2-hour window, weather can change and things can move around. And so, when I see an 80% chance of go, in a 2-hour window, I feel pretty good about our chances.
Okay, we'll take another question right here.
Thank you. Manuel Masanti with Exploración Espacial. I was just listening to you, and my question was, well, everything seems to be so smoothly from rollout, flight readiness review, all the meetings you've had. So it seems like this is it. And if it's weather cooperates, my question is, what percentage can you say, okay, we are ready for April 1st?
I'm just gonna make an appeal to the space gods. Okay, we don't taunt the machine, we don't taunt weather, we don't do any of those things. However, Charlie.
So, you know, we have over 500 launch commit criteria. And in addition to that, we have our weather criteria. We monitor them all the same, regardless of whether you've had a smooth pad flow, whether you've had, you know, challenges. They're all the same. You're going to monitor that data and make sure that the hardware is ready to fly. And the same thing on the weather. So, you know, we'll keep monitoring them all. It'd be nice if we didn't have a whole lot to talk about, but you know what? This is the thing that I love about this team, is that when you have a problem, they run to go solve it. And I think, you know, if something does come up that we don't expect, or we do get a little hiccup along the way, we're just going to work our way through it like we always do. But right now, the hardware is performing well. The weather looks, I mean, I would love to look at this weather forecast and see a 95% chance it goes. But the weather looks like something that we can hopefully work our way through if we do end up with some clouds or a little bit of precip along the way. We'll just see what the next couple of days bring.
Okay, we'll take another question in the room right here.
Jonathan Seri with Fox News. Question about quarantine procedures as the astronauts visit their families. For the families, are the quarantine procedures identical, or is it a little more lenient for them?
No, the quarantine rules are the same for everyone. It's just a question of whether they go into quarantine or not. And we have 3 different levels of three different levels you can be in. And so, like, for instance, because I'm here with you and I'm not wearing masks, if I were to need to go and talk to the crew, I would have a mask on. I would maintain 6 feet distance. These are all rules that we're now all very familiar with after our joint experience. And so generally immediate family members that are capable of it. So if you've got teenagers that are in school, they're not going to be able to go into the same level of quarantine that maybe little bitty kids would be able to. And so it'll be different for every family member, and then really how that just affects whether you're masked up, whether you're distant while you're with the crew member.
Okay, we have another one right here on the same row.
David Denault with About Space Today News. My question, you mentioned that the best way to return astronauts is to go around the moon trying anything else. Yesterday there was talking a little bit about the spacesuits that have a 6-day lifetime. What would trigger the astronauts to go into those spacesuits and survive? What would be the examples of what would cause that?
Clarify so as Emily said, we have basically continuous abort coverage through the mission that starts from when we light the deck cords to when we basically are back in the water. At some point, you know, so each mode, so like we said, we have ascent aborts that take us to different landing sites. We can abort to orbit, we can abort to lower orbital altitudes, and then contemplate that. We can do second revs of translunar injection orbits if we want to. So we do all those things. What I was pulling on earlier was after you commit to the moon, there are direct abort options where you can turn Orion around and fire the main engine and bring it home more quickly than if you were to proceed along free return. At some point, there's a knee in that curve, and it's faster to go around the moon than it is to turn around. Plus, it's safer because you have more confidence in the dispersion of the trajectory as opposed to doing a big burn when you're far away. So that's thing one. The 6-day thing you're mentioning, I believe, is we have in the program for a long time had a requirement. It's not something we rely on, but it is a crew survivability augmentation we made to the vehicle that allows the crew to stay in their pressure suits for a long period of time, and that would typically be triggered by a loss of total cabin pressure. We do have some cases where you'd have, if you had atmosphere, if you had a combustion event or something like that on the vehicle, you want to take some time to clean it up, in which case we'd put the crew in that, and those suits. That provides essentially a closed loop, hermetically sealed way for the crew and their suits to be in communication with the raw commodity of the life support system, so they can scrub CO2, they can breathe down O2, but they don't have to be in communication with cabin atmosphere. We would use that if we needed to, but again, that's a pretty far out case in terms of the risks that we're accepting, but we do have that available if we need it.
Okay, we'll take a question on this side. Right here.
Hi, Jackie Goddard for the Times of London. So we know the vehicles are looking healthy, and we know the weather may cooperate, but the gremlin in the mix is often the tanking. And I wondered if you could take us through what your confidence level is that this time we may not see the hydrogen or the helium being that gremlin, what's been done to try to preempt that being the case again. Thank you.
Yep. Okay, you want to take that one?
Thank you.
Yeah, so relative to the check valve on the helium supply to the ICPS, the upper stage tanks, we've pounded that one flat. We found a design flaw in the check valve, and we worked with the supplier and the contractor to go fix it. And then the ground systems team here did extensive testing on the check valve in the environment like it sees at the launch pad. And so we've got a high level of confidence that we've got that one knocked dead. I know folks are worried. I think people in the general public worry about our hydrogen problem. Obviously, we worry about our hydrogen problem, but it really is just a hydrogen problem given the fact that it's such a small molecule. But the team did a really good job of removing and replacing that seal at the pad. They don't have the fault tree totally closed out on that, but I think we're on a good path, and I think they're understanding of where we are relative to the quality of the seals, how long the seals can stay in that mated configuration without us having to worry about them. I think we're in really good shape for the QD on the helium side and for any LH2 leak. We had a leak on during the countdown last time. I guess it was on the lock side, on the wet dress, on the lock side, and we didn't have an LCC for that because it's oxygen and it's mixing with the air. So we fixed that while we were back in the VAB as well. Charlie, you want to add something?
Yeah, I was just going to say on that ICPS helium QD, it's in work right now. We don't wait till launch to use it. I mean, we press those bottles that are on board the ICPS. We use them for RL10 conditioning and purge, and we also use them for pressurant as well. So we have those in work every day. So we don't envision that. And as John said, we worked really closely between the SLS and the EGS team. Feel like we got that design change that we made there with the seals has been well tested and has been performing well on board the ship. So, and the only thing I would add on the hydrogen is we had a great wet dress rehearsal relative to those seals. We changed them out at the pad, as you all know. Probably had the best performing seals and the lowest leak rate that I've ever seen as part of the Artemis campaign. Performed really well, and then when we rolled back, we provided some strain relief for the flex hoses that are in the tail service mast, just to make sure that there was any kind of load that was imparted on that QD during the roll. Those have since been removed. It was never intended for them to be in place for launch, but it was just to provide a little bit of relief as you rolled.
All right, we'll take another question. Let's go to the back of the room.
Hi, Andrea Leinfelder of the Houston Chronicle. The Artemis II crew doesn't like to talk about breaking the Apollo 13 record very much because they'll say that that's not very important to them. But I'm curious, what is the distance from Earth they will go if they launch April 1st? I know it changes by day. And is it important to any one of you? Are you guys secretly hoping to pass that record?
So I happen to have the number for April 1st. The max distance from Earth is going to be 252,799 statute miles, which, yes, is a little over 4,000 miles farther than Apollo 13. I would say, at least for me personally, no. You want every mission to keep exploring and keep learning new things, and getting farther from Earth than we've ever been before is a fun statistic, but there are a lot of other things we're going to learn on this mission that are going to be a lot more exciting for me, at least.
It's not important to me. I mean, I told you guys a few weeks ago, my main thing is hitting that entry interface right down the middle and getting the crew in the Pacific Ocean safely. That's important to me, which means everything else worked great or okay, right?
Okay, we'll take another question here in the room at the front.
Hi, Paul Brinkman with Aerospace America. And a follow-up on the SEALs. I mean, our readers, I think, might be interested in, like, what did you fix about the SEALs, and is that a permanent fix? Like, you believe that won't be, that those SEALs in particular won't leak anymore? And then, I mean, I know you can't predict that, but, and then also, those SEALs have been there since the rocket, since they were traded out on the pad. Do you know how long they can stay in there before they need to be switched out again?
Well, that's why I wouldn't really be in 100% with you, because we're still in the middle of those tested, right? So, you know, it's a Teflon seal. Teflon has a tendency to creep when it's under load. So you start putting two and two together, right, and say, okay, well, how long can it be? So we're in the middle of running those tests. We don't believe so far that we're going to have that issue given this short period of time. Because if you think back in the past, for Artemis I and even for Artemis II, on the first buildup of the configuration, we set for a pretty good while, 10 months, you know, in the VAB with it in that configuration. So you can go ride it if you want to, but I mean, we're still trying to get through that. That's why I'm kind of reserve the right till we close out the fault tree.
We're learning more, right? I mean, same seals are used during Apollo, used during Shuttle, now during SLS, but the geometry of the seal has been slightly different. We've been riding more on the Teflon than we have metal on metal in the past applications. We've done, you know, bench level testing on creep rates, and we think that this may be not the dominant mode, you know, in terms of that cold flow of the Teflon away from the sealing interface. Time under compression is probably the contributor the most. So, but we have to get through all that data. I can tell you that by the time we do the third core stage, we're going to have this thing licked in terms of strain relief and different ways we can make sure we're not putting loads in the seals, because every time we do these things, we learn more about how they behave under cryogenic load as well as under compression. And so I think with the data we get here, as well as what we'll continue to do on the bench, that hopefully this is the last time we have to go through this. But again, like Honey, I'll be careful and reserve the right to be cautious.
Okay, we have time for a couple more in the room. We'll go right here.
Yeah, just as a follow-up, I'm just kind of curious, did we ever figure out the window for splashdown, or the time we might look at a return?
Yes, for an April 1st launch, on April 10th, we'll be coming home in the evening Pacific time. About what time? Roughly the 5 p.m. time frame. It'll kind of depend on actual performance across the trajectory.
Okay, we'll take our next question, second to last row in the middle, right here.
Hi, thanks, Joey Roulette for Reuters. Anyone who wants to answer, is there a launch opportunity within the April 1st to 6th window that does not involve the crew going farther than Apollo 13? I know you guys aren't really tracking that milestone that much, but our readers are really interested in it. And then I had another quick question. Can you remind us what kind of the core objective or objectives for this mission are, such that not accomplishing them on this mission for any anomalous reason would either lead you to repeat it or tweak the parameters for Artemis III? Thanks.
So I can give you the first one. By April 4th, it's close enough that it's within the error of our trajectory planning tools, and so 4th, 5th, and 6th, it's all in the wash. You're not likely to exceed that Apollo number. And Amit, you want to talk about the
so
goals?
Joey, I know Honey wants to hit the EI, and that's right. That's his job. I will tell you that it is, to me, marking the milestones it's cool, right? It's a fun thing for people to realize that people haven't gone that far. I will tell you, we will not pick a burn plan or take any additional risks of the machine that makes sure that we hit that milestone. It'll just be a happy accident of physics that it turned out that way. If in terms of what the test objectives we've lined out, one of the instrumental kind of viewpoints of thinking about the campaign as an integrated set of test objectives, that it allows you to answer that question pretty crisply. So, the life support system, obviously, the check out what we get is a critical objective. If it turns out that we don't get the performance we need after the acceleration vibe, we will, we'll come home. We're not going to commit to the moon if we don't have the performance for the docking mission. We will make changes, but we will probably commit at that point. I can't tell you. It'll depend on the nature of the failure. My only point is, the closer you are to home, the more risk you're willing to take on some of those systems as you do that. So, but that system is critical. The integrated performance of the launch abort system we're going to get as we go uphill, making sure those signals work the right way. The test of the machine and its environment, all the different test objectives we have during transit, making sure we can do that, navigation, et cetera. There's an integrated suite of objectives that I think we picked up a lot on Artemis 1 already. Recall, Artemis 1 actually inserted into lunar orbit and showed us a lot of those things, so it's not necessarily that critical. The heat shield itself, we want to learn and make sure that our modeling, we did so much modeling on the interaction between this version of the heat shield and its environment, even though we were being very careful about how we maintain the environmental control of that heat shield as we come in. We will still learn more about our modeling and make sure that, the fixes we've made for Artemis 3. So any kind of entry that puts load on the heat shield in different ways will help us parameterize the kind of integrated aerothermal and material environment that we're witnessing. And so there's a lot that we are going to learn on the flight, but I couldn't tell you today that if we didn't get a particular objective, that means we'd have to do free return again.
All right, that's all the time we have for today. Our final mission status update will come tomorrow at 1 p.m. Eastern, so we look forward to seeing you then. In the meantime, you can always stay up to date on all the latest mission and news at nasa.gov. Thanks for joining.